Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydroboration-oxidation is a syn-addition reaction that adds H and O across a double bond with anti-Markovnikov regioselectivity. The boron attaches to the less substituted carbon, and the overall addition of H and O is syn, both added to the same phase. Moving on to the next step. Identify the substrate. The starting material is 1-methylcyclopent 1Na, which has a trisubstituted double bond between C1, bearing the methyl group, and C2. Moving on to the next step. Regioselectivity. In hydroboration, boron adds to the less hindered, less substituted carbon. C2 is less substituted than C1, which bears the methyl group. Therefore, boron adds to C2 and hydrogen adds to C1. And for the final step. After oxidation, H2O2O, the boron at C2 is replaced by O with retention of configuration. So O ends up at C2, the less substituted carbon, anti-Markovnikov product. Stereochemistry. Syn addition means H and O add to the same phase of the double bond. Boron and H are delivered to the same phase simultaneously. This gives a trans relationship between the CH3 group, which is on C1, and the O group, on C2, when drawn on the cyclopentane ring, because the methyl is already on C1, and the H that adds to C1 comes from the same phase as the BH3, giving the H at C1 and O at C2 in a trans-anti relationship relative to each other on the ring. Evaluating options. Option A shows the cyclopentane product with CH3 and H at C1, CH3 up, H on wedge meaning H comes toward viewer and O at C2 on a dash, going away from viewer, indicating a trans relationship between the H at C1 and O at C2. This is consistent with syn addition of BH3 followed by oxidation giving the trans alcohol product. Option C shows a CIS relationship, both H at C1 and O at C2 on wedge, which would correspond to anti-addition. Incorrect. Options B and D show incorrect connectivity or regiochemistry. Why other options fail? B lacks proper stereochemical depiction consistent with syn addition. C shows CIS product which would result from anti-addition, not hydroboration. D shows a dimethylcyclopentane which is a completely wrong product. Therefore, the correct answer is A. Therefore, the correct answer is option A.